In this video, we're going to go over more broadly on graphs of log functions, and we're going to go over transformations. So this is actually the third time now that we have been talking about transformations that are a vertical shift and a horizontal shift. They are no different with logs than they are with exponentials, than they are with any function that we have. So when I have a function, whether it's a log or a natural log, whether it's a log that has a base of a number or a common log with a base of 10, if you have a log or a natural log and you add something to the end of it, then you're shifting it up k units. If you're subtracting k, then it's going down k units. So again, vertical shifts go in the way that we think that they're going to. Plus is up, minus is down. And then your horizontal shifts is when it happens within the function. So log of x plus h or natural log of x plus h, and then same with your minuses. And again, these are for common logs, natural logs, or any log with any base. And then these always go, your horizontal shifts are always going to go opposite of what we think. So we think plus means to the right, so it's going to the left. And we think minus is to the left, so it's going to the right. So pause this video if you need more time to write this down. And then let's go on to example 4. For the following functions, briefly describe how the graph will be obtained by the graph of the basic logarithmic function, then graph the function and state the domain and the vertical asymptote. So again, I have little asterisks here with the base and the horizontal and vertical shifts. That is all you need to be able to graph it in my math lab. Then it's going to graph it, and then it will help you kind of answer the rest of the questions. So what is my base? Well, this is log base 5. What is the horizontal and or vertical shift? So this one, you have in parentheses x plus 3. So we're talking about horizontal shifts here. And because it's a plus 3, instead of it going to the right the way we think, it's going to go to the left. So this is being shifted left 3 units. So then what is the domain? The domain is what we just did up here. To find the domain, you take what you have right here in parentheses, which is x plus 3, and we say that that has to be greater than 0. So when I solve, I'm going to subtract my 3 over, and so x must be greater than 3. So to write that in interval notation, that's -3 to infinity. So then what is that vertical asymptote? That vertical asymptote is where this domain is starting, but not including. So in this case, it's x equals -3, which should make sense. If you are shifting, let me get my graph real quick. Okay, my graph of my log is this one in red, right? If you are shifting it to the left 3, that means your vertical asymptote is now going to be 3 units over right here at -3. So this domain is going to help you be able to find your vertical asymptotes. Okay, let me get number 5 here. Example 5, we have the exact same instructions. So the base, this is a common log. Common logs have a base of 10. Then it wants to know what is the horizontal and or vertical shifts. Well, this one has 2. What you have in parentheses is your horizontal shifts, and those go opposite of what we think. So that -2 we think goes to the left, but this one's going to go to the right 2. And then what happens outside of that log is your vertical, and it is predictable. So +3 means up 3. So what is the domain? We take what you have here in parentheses, and we know that that has to be positive, but it cannot equal 0. So we set that greater than 0. So add that over, and we find that x must be greater than 2. So that is 2 to infinity, which then tells me where that vertical asymptote is. It's right here where this starts at x equals 2. Okay, example 6, it says to use the function f of x equals the natural log of x minus 1 to answer parts A through J. All right, so what is the base of my function? This is the natural log, and the natural log has a base of e. What is the horizontal or vertical shift? Well, this is inside my function, which is horizontal. So this is going to go to the right 1. We think -1 is to the left, so it's going to go to the right, goes opposite of what we think. So what is the domain? You find the domain by taking what you have here in parentheses, x minus 1, and setting it greater than 0. So you add that 1 over, and you get x is greater than 1. So in interval notation, that is 1 to infinity. What is the range? Okay, the range of any log is your all real numbers. When it's exponentials, exponentials have a domain of all real numbers. Because this is the inverse, logs have the range of all real numbers. What is the vertical asymptote? You go back over here to the domain. Because it starts at 1, you have a vertical asymptote at 1. So now part F, we need to find the inverse. So you should have some room at the bottom. And so let's use that room here at the bottom to find the inverse. So I'm going to go ahead and just write this as y equals instead of f of x. I probably should have given myself a little bit more room than that, but we'll work with it. All right. Y equals the natural log of x minus 1. So after you change your function notation to y, then the second step is to switch your x and y coordinates, or x and y variables. Okay, I have no way to solve for this inside of a log, so let's rewrite this. Natural log, we already stated, have a base of e. So this is base to equals to inside here. So this is e to the x equals y minus 1. So then the last step to solve for y is to add this 1 over. So I'm going to get y equals e to the x plus 1. So for f, find the inverse. This is e to the x plus 1. Because we solved it down here. So what is the base of my inverse? It is still e. So notice the base of both of my functions, both the function and the inverse, are the same. What is the horizontal or vertical shift of my inverse? This plus 1, let me just put this here for a second. Let me find this from that section. We have our exponential plus 1. So when you do your exponential plus 1, this is your vertical shifts, and this goes predictable. So that means this is shifting up 1. So these are both getting shifted 1, but one's going to go horizontally and one's going to go vertically. What is the domain of my inverse? So you can either use your graphing calculator and graph this, or you've already done it up here. The domain of your inverse is the range of your function. So this is -infinity to infinity, and then the range is the same as my domain. So 1 to infinity. Which again should make sense because Here is my exponential, which usually has a horizontal asymptote at y equals 0. If I am shifting it up 1, that shifts this up 1 as well, which makes my range 1 to infinity. There's 2 more examples, just like this one. Example 7, what is the base of my function? All right, my base, this is still the natural log, so this is base E. What is my horizontal or vertical shift? Well, they wrote this a little bit out of order, and I think it's to avoid confusion. Usually we see this as ln x and then -2 at the end. I think they do this -2 out front so you don't think it's the natural log of x -2. And so a lot of times you'll see something like this, the natural log of just x and then -2 added to the end. So this right here, that -2 shifts it down 2. So what's the domain? Well, to find the domain, you take what you have in parentheses or what's with that natural log, in this case just x, and you set it greater than 0. So there's no solving here. Your domain is 0 to infinity. Your range of any log, natural, common, or any base is all real numbers. The vertical asymptote is where your domain starts. So this is x equals 0. On part F, we're going to find the inverse. So I'm going to go ahead and rewrite this as, instead of f of x, y equals, and we have -2 plus the natural log of x. So we switch our x and y. So we got x equals -2 plus the natural log of y, and let's solve for y. So this time I want to get my natural log by itself. I'm going to add this 2 over first. And now I have no way to solve for this when it is in log form. So let's convert it to exponential. We've already said that this has a base of E. So we go base to equals to what's in that log. So this is E to the x plus 2 equals y. So what is the base of my inverse? It is still E. What is the horizontal or vertical shift? When you are adding or subtracting something within that exponent, that moves it to the left and to the right, and this goes opposite of what we think. So +2, we think to the right, so this goes left 2. Again, one is horizontal and one's going to be vertical. What's the domain of my interest? What's the domain of my inverse? You can put this in your calculator and get a graph, or the domain is the same as the range. Exponentials have a domain of all real numbers, and then the range is the same as my domain, 0 to infinity. Last example. For the function, answer your parts. So this time, this is the only one, and this is how your homework ends too. Everything so far has been in log form, and now we're reversing, and now this is exponential. My base is E. What is your horizontal and vertical shift? In the function is your horizontal, so +3, we think right, so this is actually going to the left 3. +2 is added to the end of my function, and that behaves as we predict it would, so that means up 2. Okay, so I'm actually going to put this one in my calculator real quick, so it can help me with the domain and the range. With logs, we have domain restrictions, so that helps me with the domain and range. These don't. So e to the x plus 3 plus 2, and we graph, and here's my exponential. And as we said, it goes left 3 up 2, and so we can see it has been shifted left 3 and up 2. So usually it has that horizontal asymptote right here, y equals 0, because it shifted up 2. Your horizontal has also been shifted up, and you have a horizontal asymptote at y equals 2. And you can kind of see that when you look here at the graph or at the table. As you go further negative, this is getting closer and closer to 2, and then your calculator will eventually just round it to 2, but it is not actually ever approaching 2. Well, it's approaching 2, it's never reaching 2. So when I look at my graph, my domain is negative infinity to infinity. Your domain of exponentials are all real numbers. But then the range is that horizontal asymptote to infinity. So 2 to infinity. So let's find the inverse. I'm going to write this with y again. So y equals e to the x plus 3 plus 2. Switch our x and y. So x equals e to the y plus 3 plus 2. And now solve for y. To solve for y, I need to get this exponential by itself. So I'm going to subtract my 2 over. I have no way of solving for a variable in the exponential place. So we need to rewrite this as a log and see if that helps. So this goes base to equals to exponent. So if my base is e, then I know this is the natural log. Base to equals, and then to my exponent. And now my last step to solve for y is to subtract that 3 over. So we get y equals the natural log of x minus 2 minus 3. What is the base of my inverse? Natural logs have a known base of e. My horizontal and vertical shift. Inside is horizontal and it goes opposite of what we think. So we think negative 2 is to the left. So this is to the right 2. And what happens to the end is your vertical, and it goes what we think. So minus 3 is down 3. Then what's the domain and what's the range? Well, the domain is the same as my range. So this is 2 to infinity, which does make sense. If you did x minus 2 is greater than 0, you add your 2 and x must be greater than 2. And then your range is the same as your domain, which is all real numbers. And that is what your range will always be with logs.